Supriya madam.
Good afternoon, everyone. For today's session, I welcome one and all. Today, the happy thing is we are going to complete 15th episode of Creative Talks. And as we know that Creative is a knowledge square, having a knowledge square caption. Knowledge square means sharing a knowledge, gaining a knowledge. ಸೊ ಕ್ರಿಯಾಕ್ಟಿವ್ ಅನ್ನೋದು ನಮ್ಗೆ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ ಕ್ರಿಯಾಕ್ಟಿವ್ ಅನ್ನೋದು ಆಕ್ಟಿವ್ ಆಗಿರ್ಬೇಕು ಅಂದ್ರೆ ಕ್ರಿಯಾಕ್ಟಿವ್ ಆಗಿರ್ಬೇಕು ಅಂತ. ಸೊ ಬೋತ್ ಟುಗೆದರ್ ಕ್ರಿಯಾಕ್ಟಿವ್. ಸೊ ಕ್ರಿಯಾಕ್ಟಿವ್ ಕ್ಯಾಪ್ಷನ್ ಬಂದು ನಾಲೆಜ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಹೇಳಿದ್ರೆ ನಮ್ಗೆ ಕೊಡೋದ್ರಿಂದ ಶೇರಿಂಗ್ ಆಫ್ ನಾಲೆಜ್ ಅಂಡ್ ಗೈನಿಂಗ್ ದಿ ನಾಲೆಜ್, ಬೋತ್ ವಿ ಕ್ಯಾನ್ ಸ್ಕ್ವೇರ್ ಅವರ್ ನಾಲೆಜ್. ಸೊ ಈ ಕ್ಯಾಪ್ಷನ್ ಇಂದ ನಾವೇನು ಅಂತಂದ್ರೆ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಇರೋದು. ಸೊ ಇಲ್ಲಿ ಬರೋ ಅಂತ ಪ್ರತಿಯೊಂದು ಸ್ಪೀಕರ್ಸ್, ರಿಸೋರ್ಸ್ ಪರ್ಸನ್ ಏನಿರ್ತಾರೆ ಅವರು ನಾಲೆಜ್ ನ ಶೇರ್ ಮಾಡ್ತಾರೆ. ಇಲ್ಲಿ ಬರೋ ಅಂತ ಪಾರ್ಟಿಸಿಪೇಷನ್ ಏನಿರುತ್ತೆ ಆ ನಾಲೆಜ್ ನ ಗೈನ್ ಮಾಡ್ಕೊಳ್ತಾರೆ. ಸೊ ಇದ್ರದ್ದು ಕಾನ್ಸೆಪ್ಟ್ ಮೇಲೆ ಕ್ರಿಯಾಕ್ಟಿವ್ ನ ನಾವು ಬಿಲ್ಟ್ ಮಾಡಿರೋಂಥದ್ದು. ಸೊ ಕ್ರಿಯಾಕ್ಟಿವ್ ಅಲ್ಲಿ ನಮ್ಗೆ ಪ್ರತಿ ವೀಕೆಂಡ್, ಎವ್ರಿ ವೀಕೆಂಡ್ ವಿ ಆರ್ ಕಂಡಕ್ಟಿಂಗ್ ವೀಕೆಂಡ್ ಸೆಷನ್ಸ್ ಫ್ರಮ್ 3 to 4 ಸೆಷನ್ ಅಲ್ಲಿ ನಾವು ಒಂದು ಕ್ರಿಯಾಕ್ಟಿವ್ ಸೆಷನ್ಸ್ ಅಂತ ನಾವು ಪ್ರತಿ ವೀಕ್ನು ಕಂಡಕ್ಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಬರ್ತಾ ಇದೀವಿ. ಡಿಫ್ರೆಂಟ್ ಟಾಕ್ಸ್ ನ ಅರೇಂಜ್ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದೀವಿ. ಸೊ ಈ ಟಾಕ್ ಏನಿದೆ ಇದು ಒಂದೇ ಸ್ಟ್ರೀಮ್ ಗೆ ರಿಲೇಟ್ ಆಗ್ಬಾರ್ದು ಅಂತ ಡಿಫ್ರೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ, ಫೀಲ್ಡ್ಸ್ ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಇವತ್ತು ಕೂಡ ಒನ್ ಆಫ್ ದಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಟಾಪಿಕ್ ಅಂತಾನೆ ಹೇಳ್ಬೋದು, ಟ್ರೈನಿಂಗ್ ಟು ಬಿ ಎ ಪೈಲಟ್. ಸೊ ಇವತ್ತಿನ ಸೆಷನ್ಗೆ ನಮ್ಗೆ ಸ್ಪೀಕರ್ಸ್ ಇದಾರೆ. ಸೊ ಸುಭಾಷ್ ಸರ್ ಆಗಿರ್ಬೋದು, ರಾಘವೇಂದ್ರ ಸರ್ ಆಗಿರ್ಬೋದು, ಪರೇಶ್ ಸರ್ ಆಗಿರ್ಬೋದು, ಅವ್ರ ಬಗ್ಗೆ ಒಂದು ಇಂಟ್ರಡಕ್ಷನ್ ಬರುತ್ತೆ ನಿಮ್ಗೆ. ಸೊ ಬಿಫೋರ್ ದಟ್ ನಾನು ಎಲ್ಲಾರನ್ನೂ ಈ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ವೆಲ್ಕಮ್ ಮಾಡಕ್ ಇಷ್ಟ ಬೀಳ್ತಾ ಇದ್ದೀನಿ. ಐ ವೆಲ್ಕಮ್ ಒನ್ ಅಂಡ್ ಆಲ್ ಫಾರ್ ಟುಡೇಸ್ ಸೆಷನ್. ಸೊ ಈ ಕಾರ್ಯಕ್ರಮದ ಮೈನ್ ಮೋಟೋ ನಾನ್ ಟೆಕ್ಸ್ಚುಯಲ್, ನಾನ್ ಅಕಾಡೆಮಿಕ್ ಸಿಲೆಬಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ನಾನ್ ಪ್ರಾಫಿಟಬಲ್. ಸೊ ಈ 3 ಥಿಂಗ್ಸ್ ನ ಇನ್ಕ್ಲೂಡ್ ಆಗಿ ಕಂಡಕ್ಟ್ ಮಾಡ್ತಿರೋ ಅಂತದೇ ಕ್ರಿಯಾಕ್ಟಿವ್ ಕ್ಲಾಸಸ್. ಸೊ ಇವತ್ತಿನ ಕ್ಲಾಸ್ಗೆ ಬಂದಿರೋಂತ ಸ್ಪೀಕರ್ಸ್ಗೆ ಇನ್ವೈಟ್ ಮಾಡ್ಬೇಕು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಐ ಹ್ಯಾಂಡ್ ಓವರ್ ಟು ಶ್ರೀನಾಥ್ ಸರ್.
Good afternoon or good evening, whatever depending on the location. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಇವತ್ತು ಒಂದು as a part of our my voice is audible now madam?
Yes sir.
Yeah, it is audible.
As a part of our motto to make non-profit efforts to spread the knowledge so that the students will gain knowledge and make benefit out of our talks in their professional career. ನಮ್ಮ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳು, ವಿಶೇಷವಾಗಿ ಗ್ರಾಮೀಣ ಪ್ರದೇಶದ ವಿದ್ಯಾರ್ಥಿಗಳು, ನಾವು ಇಲ್ಲಿ ಅರೇಂಜ್ ಮಾಡುವಂತ ಟಾಕ್ಸ್ ಇಂದ ಬಹಳಷ್ಟು ಉಪಯೋಗ ಪಡ್ಕೊಂಡು ಅವರ ಒಂದು ಮುಂದೆ ಕೆರಿಯರ್ ಅಲ್ಲಿ ಅದನ್ನ ಬಳಸ್ಕೋಬೇಕು ಅನ್ನೋ ಉದ್ದೇಶದಿಂದ ಇವತ್ತು ಟುಡೇ ಇಸ್ ಬೀಯಿಂಗ್ ಎ ಸ್ಪೆಷಲ್ ಡೇ. ಒನ್ ಆಫ್ ದಿ ಸ್ಪೆಷಲ್ ಟಾಕ್ಸ್. ಜನರಲಿ ಎವ್ರಿ 2 years ಏರೋ ಶೋ ಆಗುತ್ತೆ ಬೆಂಗಳೂರಲ್ಲಿ. ಸಮ್ ಕಿಡ್ಸ್, ಇಫ್ ದೇ ಆರ್ ಫೆಮಿಲಿಯರ್ ವಿತ್ ದಟ್, they will also understand what is the meaning of today's talk. So in that direction we had a special privilege of approaching one of our very close friend actually, Subhash Chandra GL, who is our neighbor also, but he is not in Bangalore right now. Avaru Bangalore alli illa iga, but he is in Germany serving as a aviation enthusiastic and as a pilot. ಅವರ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ವಿಚಾರ ಹೇಳಬೇಕು ಅಂದ್ರೆ, he did his BSc electronics, but he acquired what you called as a license ಅಂತಾರಲ್ವಾ, ಪೈಲಟ್ ಲೈಸೆನ್ಸ್ ಅಂತೀವಿ ನಾವು. ಸಾಮಾನ್ಯಕ್ಕೆ ಮಕ್ಕಳಿಗೆ ಗೊತ್ತಿರುತ್ತೆ 2-wheeler ಲೈಸೆನ್ಸ್, ಕಾರ್ ಲೈಸೆನ್ಸ್, ಆ ತರ ಅನ್ಕೋಬಾರ್ದು. ದಿಸ್ ಇಸ್ ಅ ಡಿಫರೆಂಟ್ mechanism altogether. He has acquired the pilot license maybe that is in 2008. On that he started serving in the aircraft department or aircraft domain. Later he became an instructor. Amele he had more than 20 years of business and development experience. Your basic education is an electronics engineer by education. Adaldane he is a social entrepreneur also. Kumar social activities all involve ಆಗ್ತಾರೆ. I used to see him serving Ayyappa temple also with a dedication and service. Adhe tara he will be talking to kids and inspiring the kids. He is a very enthusiastic person. Airfield or aircraft field alli he gives us a lot of knowledge. Today he is with us, with my sincere request, and Supriya has pursued to invite him here, and he has readily agreed, and we are all fortunate enough ನಮ್ ಜೊತೆ ಅವರು ಇದ್ದಾರೆ. ಸೊ ವಿ ಶುಡ್ ಬಿ ಗ್ರೇಟ್ಫುಲ್ ಟು ಹಿಮ್ ಫಾರ್ ಶೇರಿಂಗ್ ಹಿಸ್ ನಾಲೆಡ್ಜ್. ಜನರಲಿ ಈ ತರದ ನಾಲೆಡ್ಜ್ ನ ಶೇರ್ ಮಾಡೋದು ತುಂಬಾ ಕಷ್ಟ ಇರುತ್ತೆ. ಸೊ ಹಿ ಹಸ್ ವಾಲಂಟ್ರಿಲಿ ಅಗ್ರೀಡ್, and we are very thankful. Subhash Chandra sir, I welcome you for this today's talk. And also the greatness of Subhash Chandra, I only requested him, you only give talk sir anta. So team work ಅನ್ನೋದಕ್ಕೆ example is this domain ಇದಲ್ವಾ, ಏನು ಏರ್ಕ್ರಾಫ್ಟ್ ಅಥವಾ ಏವಿಯೇಷನ್ ಅನ್ನೋ, ಇಟ್ಸ್ ಎ ಟೀಮ್ ವರ್ಕ್ ಅನ್ನೋದಕ್ಕೆ ಟುಡೇ ಸ್ಟಾಕ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ an example. He has associated few more other speakers. Captain Raghavendra right now he is available with us. He is working in a reputed airlines in Chennai. He has a field experience that he will be sharing with us. So we will welcome you sir, and it's a very honor to have you and to deliver a talk to our kids. Few more people are mentioned here. Of course they will be joining in later time. Captain Paresh Kumar ಮತ್ತು Captain Shashi ಅಂತ. So we will be happy to listen to them. I would welcome them also, and I request all students to get maximum benefit out of this talk. And over to Supriya. Thank you once again for accepting sir. Over to Supriya.
Thank you sir.
Thank you Srinath sir. ಒಂದ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಏನು ಅಂದ್ರೆ, ಚಾಟ್ ಬಾಕ್ಸ್ ಇದೆ, ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡ್ಬೋದು. ಎಲ್ಲಾರ್ಗು ಮ್ಯೂಟ್ ಆಗಿದೆ, ಏನಾದ್ರು ಕ್ವಶನ್ಸ್ ಇದ್ರೆ ಹ್ಯಾಂಡ್ ರೈಸ್ ಮಾಡ್ಬೋದು. ಸರ್ ಅದಕ್ಕೆ ಆನ್ಸರ್ ಮಾಡಕ್ ಟ್ರೈ ಮಾಡ್ತಾರೆ ಇನ್ ಬಿಟ್ವೀನ್ ಅಲ್ಲಿ, ಇಲ್ಲ ಅಂದ್ರೆ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಕ್ವಶನ್ ಸೆಷನ್ ಅಲ್ಲಿ ಅದನ್ನ ಕ್ಲಿಯರ್ ಮಾಡ್ತಾರೆ. ಸೊ ಸರ್ ಸುಭಾಷ್,
one second Supriya, one second before you hand over to Subhash, I just want to tell all our audience that today's talk is on how to become a pilot or training to be a pilot. Next week al barodana ನೀವು brief ಮಾಡಿ ಅಂತ just I request you.
ನೆಕ್ಸ್ಟ್ ಕಮಿಂಗ್ ಮಂತ್ ಏನಿದೆ, ಸ್ಯಾಟರ್ಡೆ ಆನಂದ್ ಅವರು ನಮ್ಗೆ ಒಪ್ಕೊಂಡಿದ್ದಾರೆ ಕ್ಲಾಸ್ ಮಾಡ್ಕೊಡೋದಿಕ್ಕೆ. ಅವರು ಪ್ಲಾನಿಟೋರಿಯಂ ಅಲ್ಲಿ ಸೈಂಟಿಸ್ಟ್ ಆಗಿ ವರ್ಕ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಅವರು ಡಿಫ್ರೆಂಟ್ ಆಕ್ಟಿವಿಟೀಸ್ ನ ಕಂಡಕ್ಟ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ನಮ್ಗೆ ಟೆಲಿಸ್ಕೋಪ್ ಅಲ್ಲಿ ಗ್ರಹಣದ ಬಗ್ಗೆ, ಎಕ್ಲಿಪ್ಸ್ ಬಗ್ಗೆ ಆಗ್ಬೋದು, ಇದ್ರ ಬಗ್ಗೆ ಅವೇರ್ನೆಸ್ ಕೂಡ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಿರ್ತಾರೆ. ಸೊ ಅವರು ನಮ್ಗೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅನ್ನ ಕಂಡಕ್ಟ್ ತಗೊಳ್ತಿದ್ದಾರೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕಮಿಂಗ್ ಡೇಸ್ ಅಲ್ಲಿ ನಾವು ಇನ್ನಷ್ಟು ಡಿಫ್ರೆಂಟ್ ಟಾಪಿಕ್ಸ್ ಕಡೆಗೆ ಹೋಗ್ತಾ ಇದೀವಿ. ಅವರು ಟೆಲಿಸ್ಕೋಪ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾರೆ, ಡಿಫ್ರೆಂಟ್ ಟೆಲಿಸ್ಕೋಪ್ಸ್ ಬಗ್ಗೆ ನಮ್ಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ಸ್ ಕೊಡ್ತಾರೆ. ಅದ್ರ ಬಗ್ಗೆ ಒಂದು ಆಕ್ಟಿವಿಟಿ ಕೂಡ ಮಾಡ್ಬೇಕು ಅನ್ನೋದು ಪ್ಲಾನ್ ಇದೆ. ತುಂಬಾ ವಿಷಯಗಳನ್ನ ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ಬೇಕು ಅನ್ನೋದು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅದ್ರಲ್ಲಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಅಲ್ಲಿ ಆನಂದ್ ಅವ್ರ ಕ್ಲಾಸ್ ಇರುತ್ತೆ. ಓಕೆ ಸರ್, ಸುಭಾಷ್ ಸರ್, over to you.
Thank you very much madam. Thank you Srinath sir, and thank you
sir. ನಿಮ್ ಕಡೆಯಿಂದ brief introduction ನಮ್ಮ ಮಿಕ್ಕಿರೋ ಸ್ಪೀಕರ್ಸ್.
Okay, sure madam. So I thank you both for giving us an opportunity to speak on this particular topic, training to be a pilot. So I am basically ನನ್ನ ಹೆಸರು ಸುಭಾಷ್ ಚಂದ್ರ. So I am a commercial pilot license holder, and prior to this like I was working in the field of business development, that is sales and marketing. And in 2007 I went to Canada, and I did my commercial pilot training. I did it on single engine and also on multi-engine aircraft, that is Piper Seneca. And in India I was flying with non-scheduled sector. Non-scheduled is they are not into scheduled airlines, but they are into commercial, but it's a non-scheduled like charter aircrafts. So I was flying there. I was flying an aircraft called King Air C90. It's a turboprop aircraft. And currently now I've moved abroad, so I'm working over here. So I usually take this interest in educating the young children's basically who wanted to become pilot or who want to just come into aviation. So I just basically give what are the things which has to be done and what are the hurdles we face, so that we can brief you on this so you have a better idea. Joining with me is Captain Raghavendra Varma Alluri. So Raghavendra I and Raghavendra, we met together in Canada. We were both in the same flight school. So Raghavendra has completed his graduation in flight ops, and he is also a commercial pilot license holder, and he has done his type rating on Airbus 320, and currently he's flying as a first officer in Indigo. So he's a very active flyer. He flies every day in and out, so very difficult to catch him. So somehow, like today and tomorrow, and he's not working. So thank you, Raghavendra, for joining us.
It's my pleasure, Subhash Anna. I call him Anna directly. It's more like a brother to me since we met in Canada. Our life started in aviation with Cessna 150. We should never forget that. And one of the very good aircraft to start your training with. So it's a pleasure to be here. Thank you, Subhash Anna, for this opportunity. And Srinath sir and Supriya Garu, thanks a lot for this.
And we also have two more speakers. Captain Paresh Karmarkar. So Paresh, he is having more than 30 plus years of experience in aviation, sports and adventure activities. He is also a commercial pilot license holder. He did his pilot training in 2007, and he is now running his own company called Hanka Aviation, which is basically promoting aerosports. Now, this aerosports, like it is very new in India. Like not many people know about this particular avenue. What are the things which are associated in aerosports? So he is having his company here in Bangalore, and he conducts certain activities like paragliding, parasailing in Jakku. Paresh, can you be audible? Is it possible? If you are driving, then I don't want to disturb you. I think so. You have to mute. If you're driving, then I don't want to disturb you. Yeah.
Unmute madhu. Co-host madhu.
Yeah. Yeah. Hi. Hi. All of you there. It is a pleasure to be on this group for today's discussion. I am not driving. I am very close to the location, and the unfortunate thing is it has started raining. So once I reach the location, I will keep you updated on the different aerospace activities that I had planned to show to the. But I'm available on the audio now. Let's continue the discussion, and the moment the weather is good here, I will be displaying the paramotor to the kids, and we will continue the discussion on the technical aspects, that is how an aircraft fly, all those things that Subhash has planned to discuss. Yeah, please continue, Subhash.
Yeah. Thank you, Paresh. Thank you for joining in. Now, why we chose this particular topic, like training to be a pilot. There were many children or many kids, even many professionals who who had this enthusiasm to be a pilot. So they were especially students after completing their graduation, or some after completing their +2, they are moving into graduation. So they have lots of doubts. Is it a right time to step into aviation, and what are the process which has to be followed? So some have some idea, some they don't have much idea. So I thought I keep whenever such students like talk to me or I meet them, I just give a brief and say them what and all to do to get a pilot license, which is a proper way, what has to be done first, so that you don't waste much of time and then you don't waste much of money. So today's, so I thought we will try to put this particular video because most of the flying aspects, most of them, they'll be knowing it, or you can also know it by seeing onto some YouTube videos. But the other aspects, I thought I will cover it. So starting, what I will do is I will just start up, just share the screen.
I think it is unshared. You have to share it again.
Yes.
Yes, sir, shared.
So the topics for discussion is a small brief introduction on history of flight, and we'll also be talking on basics of aerodynamics. So what I have done is, see, actually this would be best if we are able to like show some working model, or we are able to show the aircraft and then explain you. That will be much more better. But the problem is we have to take a lot of permissions in order to like video shoot such programs or such talks. We have to take prior permission. Sometimes we get permission, sometimes we don't get. So there are a lot of hurdles. So what I have done is I have picked up few videos from YouTube. So as we keep discussing on various topics, I will be playing this video so that you get a better understanding of the topics. And we'll also be like the legal requirements to get the license, like what and all you have to do first. All these steps I have briefed to my best knowledge. So I request Raghavendra, Captain Raghavendra and Captain Paresh, you can also pitch in, like in case you want to add up a few things over here. And then I have also shared a few things on training syllabus. Basically, when you go for pilot training, that is commercial pilot license training, what are the things you do, or what are the trainings you do, what are the different maneuvers you do during this process of training. I have just touched on those topics. And then we'll also discuss on type rating. Like after getting your commercial pilot license, that is not enough for you to readily get employed into the airlines. So you have to do further training. So which we call it as type rating. So here Captain Raghavendra will be briefly explaining, because he has undergone these types of training, type rating on Airbus 320. And then finally we'll be speaking on careers. Basically in this aviation, what are the other career options which are available. So we will touch on these topics, and after that I will hand it over to Paresh, who will basically be speaking on and showing you some hands-on demonstration on aviation sports. That is, currently he has organized a paraglider, powered paraglider. So he'll be just showing you the powered paraglider, how the things work on it, and how to fly a powered paraglider. Okay. So as you all know, so as you all
Audio
know,
is fine. Audio is fine.
Audio is fine, also. Okay. There were many people who started working in the to make a working flying model. There were many people in history who have contributed bits and pieces here and there for flying. But the actual flying model was brought by the Wright brothers, Wilbur and Orville Wright. They were in America. So they both brought the first working model of the aircraft. Even they also faced a lot of problems, like they had a lot of failures when they started with making this aircraft models, flyable aircraft models. Then they did a lot of research. They found out, okay, what are the required things. Then they educated themselves on these, and then they had their first flight, which was on 1903 on December. So I'll show you a small video on this thing. How did they achieve this first flight? Sir,
The Wright brothers.
Okay, I'll make it as, okay, that's great.
Combined all of the latest technology during their time and developed technology of their own to bring the world the first controlled, powered, and sustained flight. Much like Leonardo da Vinci, the Wright brothers spent a great deal of time observing birds in flight. Read about the works of George Cayley and the hang gliding flights of Otto Lilienthal to learn more about aerodynamics. Following a successful glider test, the Wrights built and tested a full-size glider at Kitty Hawk, North Carolina. They chose Kitty Hawk.
So are you able to hear me?
Yes, sir.
Yeah.
As their test site because of its wind, sand, hilly terrain, and remote location. In 1901, at Kill Devil Hills, North Carolina, the Wright brothers flew the largest glider ever flown, with a 22-foot wingspan, a weight of nearly 100 pounds, and skids for landing. However, many problems occurred. They decided to build a wind tunnel based on Francis Wenham's research to test a variety of wing shapes and their effect on lift. During 1902, the brothers flew numerous test glides using their new glider. Their studies showed that a movable tail would help balance the craft based on the center of gravity, and the Wright brothers connected a movable tail to the wing warping wires to coordinate turns. After months of studying how propellers work, the Wright brothers designed a motor. This was attached to a new aircraft sturdy enough to accommodate the motor's weight and vibrations. The craft weighed 700 pounds and came to be known as the Flyer. The Wrights further redefined the wings by covering the bottom surfaces with fabric. This resulted in a smoother overall wing surface, which enhanced its aerodynamic efficiency. The brothers continued to apply the fabric in the direction of the weave at a 45-degree angle to increase the stiffness of the wings. One of the most innovative aspects of the 1903 Flyer was its propeller. The Wrights decided to treat the propeller as if it were a rotating wing. They reasoned that the same physics that generated an upward force or lift on a curved surface in a flow of air would also produce a horizontal force or thrust when such a surface was positioned vertically and rotated to create the airflow. The brothers built a movable track to help launch the Flyer. This downhill track would help the aircraft gain enough airspeed to fly. After 2 attempts to fly this machine, one of which resulted in a minor crash, Orville Wright took the Flyer for a 12-second sustained flight on December 17, 1903. This was the first successful, controlled, powered, and sustained heavier-than-air human flight in history. In 1904, the first flight lasting more than 5 minutes took place on November 9th. The Flyer 2 was flown by Wilbur Wright.
So hope this video was very informative. It has explained the struggle of Wright brothers. I am audible now?
Yes, sir.
Yes, yes.
Yeah. It is not but the first instance like they have made this mission, because they didn't have initially when they started, they didn't had ideas. They thought, okay, just by having a propeller and a motor and then having a bird-like wing structure, we can make flying missions. But later on, they discovered, they learned that the shape of the wing, altering the shape of the wing, is one of the main aspect where you can achieve flight. The next topic, what I am going to discuss would be basically on the aerodynamics. What makes an aircraft actually fly? What is the thing which is generating the lift in the aircraft? Of course, everyone knows that without wings, the aircraft can't fly. But only making a wing, what is the shape of the wing? All these things we will see it in the next topic. So before I get into this particular topic, I thought I'll share a small video on the evolution of aircrafts, from the Wright brother, how the aircraft has evolved to the present time days, the commercial aircrafts. So we'll have a small watch on that. So from being a small aircraft carrying single passenger, slowly to a present day, we are carrying hundreds of passengers at a very high level of comfort. So this is what the aviation has traveled from 1903 to 2020. So roughly around 120 years. Okay. Yeah. So now we'll be speaking on basically how a lift is generated. When Wright brothers, they made the wing and they gave a particular shape for the wing, which we call it as a camber. It is a small, if you see on the cross section, you can see it is a C type of a camber section, where when the air flows over this particular structure, then there is a pressure difference which is created, and Due to this pressure difference, the lift is generated. So I have a small video, because just by speaking, like many children will not be able to understand this concept. So I have a small video to show over here, where it is clearly, they give a very good explanation as how exactly this lift is generated. So basically, before starting this thing, when we talk about aircraft, so there are three main parts. So one is what we call as a fuselage, the main body of the aircraft, where the other two elements get fixed. Then we have the main plane or the wing, and then the other section is called the tail plane or the tail of the aircraft. So first we'll watch the main plane, how the lift is generated.
Hello. So today we're going to be taking a look at how planes actually fly. So basically, planes fly because they have wings. So thank you all very much for watching. No, seriously, this video is going to take a look at what the wings are actually doing, which causes a plane to fly. Now, I'm no physicist, so please forgive me if I say something out of turn during this video. So firstly, we'll need a wing. This shape here represents...
So the shape here basically is a cross section. Like when you see a wing from a cross section, most of the aircrafts, almost all the aircrafts will have this particular section. Might be, it can be when you go into bigger planes, you can see it much evidently. But when you come to fighter aircrafts, this element, this section is there, but it is very much, because since it's moving at a very high speed, so it'll the camber section will be slightly thinner.
Since the cross section of an aircraft wing, also called an aerofoil. This view is if you were looking at it from side on, i.e. from the wingtip looking towards the plane. So one of the most common but incorrect theories which is taught is something called the longer path or equal transit theory, which is based on the Bernoulli principle. So the explanation that this theory gives is that the airflow, the air which is hitting the wing, splits as it hits the front of the wing. The air passes over and under the wing and rejoins at the back of the wing at the same time. So for this to happen, the air flowing over the top of the wing has a further distance to cover over the curved surface. Therefore, it's...
So here I'd like to interrupt. Children's, what you have to imagine is when you say about air is also a fluid. So now, as you see, water is a fluid. Same way, you should also imagine air also as a fluid. Then you will be able to visualize this concept much better.
Speeds up. As the air speeds up, it causes an area of low air pressure above the wing. The air which passes underneath the wing slows down because it has a shorter distance to travel, and this causes high air pressure below the wing. The end result, this theory states, is that it's this pressure difference above and below the wing which causes the wing to move upwards, and this upwards force is more commonly called lift. Now, there are a few aspects of this theory which are correct, but it doesn't tell the full story. So I'm going to give you the correct answer first and then try and explain what's going on after. So the correct answer is that lift is created because a wing or an aerofoil is turning the airflow and directing it downwards. It's not a pressure difference which creates lift. So here comes my attempt at explaining it, and again, physicists, please be gentle with me. So the airflow hits the front of the wing and splits, the same as before. Also, Bernoulli was correct when he talked about the difference in air pressure above and below the wing, and he was also correct in saying that the air which flows over the top of the wing speeds up. Now, the air which passes over the wing kind of sticks to the top of the wing and follows the curve of the upper surface. This sticking phenomenon is known as the Coanda effect. As the airflow leaves the wing at the back, it leaves at a slight downward angle because of that curve. That downward deflection also affects the air which passes under the wing and also turns it in a downward direction. It's this turning of the airflow which causes lift. You can generate more lift in two ways. The first is by increasing the speed at which the air passes around the wing. This is generally attained by... You can also increase something called the angle of attack. This is the angle of the wing relative to the airflow. So in this example, you can see that the wing is pretty much pointed directly into the airflow. However, if we increase the angle of attack, you can see that the wing is tilted backwards. This creates more lift because the airflow is turned downwards at a sharper angle. Now,
I just want you to remember this particular word, like angle of attack. So angle of attack is the angle made by the wing with the relative airflow. So you can see now when the plane is taking off or when the plane is landing, so especially when the plane is taking off, you increase the angle of attack. But later on, when I speak about different maneuvers, what would be taught for you in training, then we speak something about stalls. So there also you come across the same phenomena like angle of attack. Suppose this angle of attack increases, that means you increase the angle of attack to a certain degree, like around 45, then 50, then at one point the airflow is disturbed over the wing, and once the airflow is disturbed, there is no lift which is generated. So the aircraft loses lift, and it starts, due to the weight, it starts now falling down. So this I'll also again come back to you when I speak about stalls, spins, spirals, all this.
Subhashana, I would like to interrupt. Maybe we should tell them about the four forces of flight.
Yeah, that is coming. Yeah,
okay.
Raghu, that is coming in the next video. Yeah.
Now there is a danger to increasing the angle of attack. If you increase that angle too much, there will come a point where the airflow cannot turn and follow the top of the wing. When this happens, the airflow will separate from the top of the wing. This is what happens when an aircraft stalls. There is no steady flow of air over the wing, therefore the wing stops producing lift and the plane begins to literally fall out of the sky. Now, there are a couple of devices used on aircraft which help increase the amount of lift that a wing can generate. The main one you have are flaps. The flaps on any aircraft are designed.
So I'll come to this topic later. Now, so now you have an idea of how exactly the lift is generated in an aircraft. So the section is called airfoil. The main lift producing surface is the wing, and then an airfoil section, that is the shape of that particular section, the wing, we call it as airfoil. So that is that enables the aircraft to generate lift, and we use engines to develop this particular thrust so that more and more wind flows over the wing. So next I will just touch on frame. So basically, as I told you earlier, like we have the fuselage, then we have the wing, and we have the tailplane. These are the three main parts of the aircraft. Fuselage is nothing but the main body of the aircraft, starting from the nose to the tail end. So to the fuselage, that is the tubular structure, we attach the wing, and then we attach the tail. Now we'll come across what are the forces generally which are acting on the aircraft. So here also I have a small video which will explain the concept better. So we'll directly move on to this video.
Tower Blue 650 full 50, 27 left for the land, 230, 20. 7 left clear.
An aircraft's motion can be described as rotation around three axes. These three axes are the vertical axis, the longitudinal axis.
So these three are the imaginary axes. So basically here he is talking about a longitudinal axis, which is running from your nose to the tail. It's an imaginary line. Okay, all these three are imaginary lines. Next, we have a lateral axis, which is running wing-wise. And then we have a vertical axis, and all these axes are meeting at a point right angles to each other. Yeah.
and the lateral axis. The axes of an aircraft are three imaginary lines that pass through an aircraft's center of gravity. All three axes pass through the CG at 90-degree angles to each other. The longitudinal axis passes through the CG and runs from the nose to the tail of the aircraft. The lateral axis runs parallel to a line from wingtip to wingtip. The vertical axis passes through the CG at right angles to the other two axes, running through the top of the aircraft to the bottom of the aircraft. Whenever an aircraft changes its flight attitude or position in flight, it rotates about one or more of these three axes. The motion about an aircraft's vertical axis is called yaw.
Now just
yaw,
see,
or rotation about the vertical axis, is controlled by the rudder.
now this yaw motion is the motion about the vertical axis, but it's happening on the longitudinal plane. So now the rudder is one of the to do this particular yawing motion, we use rudder. So as shown here in this particular video, so the rudder is activated from the cockpit using rudder pedals. So we have pedals on both the legs. So you press the right right leg, you have the right rudder deflected, and you press the left, then you have the rudder moves to the left. So it's basically a chain and pulley type of an arrangement.
Located on the tail of the plane.
See the motion of rudder here.
The motion about an aircraft's lateral axis is called pitch.
Now you see, when they're doing the pitch, the control responsible for doing the pitch is the elevator, which is at the tail of the aircraft.
Pitch in conventional aircraft is controlled by the elevator located on the tail of the plane. The aircraft's motion about its longitudinal axis resembles the roll of a ship from side to side. In fact, the names used to describe the motion about an aircraft's three axes were originally nautical terms. They have been adapted to aeronautical terminology due to the similarity of motion of aircraft and seagoing ships. Roll is also referred to as bank and is controlled by the ailerons located on each end of the wing. The two ailerons deflect in opposite directions of each other. The reason for this is that when one wing goes up, the other must go down. As mentioned earlier, these three axes all pass through the aircraft's center of gravity. The rudder, ailerons, and elevator are primary control surfaces. Flaps are a secondary control surface. They are not used to control movement around any of the
Tower Blue, 57 left for the land.
So we'll come to the secondary control surfaces later. Now, I think so you have a brief idea about what are the three axes and what motions are happening on these three axes. So you have the yaw, you have the roll, and then you have the up and down motion, which is controlled by the elevators. Now, all these three axes in a normal flight, they pass through the center of gravity. Okay. In case your center of gravity, all the three axes are not particular to the center of gravity, or you have excess of weight in the nose or excess of weight in the tail, then the aircraft will be either tail heavy or it will be like nose heavy. So every pilot, before taking off or before even starting his flight, would do a weight and balance of the aircraft, which we call it as trim sheet. he will check what is the amount of weight and what is the amount of fuel, what is the amount of cargo, how many passengers, all these things what are carried in the aircraft. They weigh everything, and then they plot all these values onto a graph and find out where is the CG, where is this my center of gravity. So based on this, they do adjustments on the cargo. I think so. Captain Raghavendra will be able to add something to it because he does it on daily basis.
Yeah. So regarding the CG, there is a set limit given by the manufacturer of a specific aircraft. So if you take, for example, a Cessna itself, during the training, we used to get a graph, and there's a forward CG limit and an aft CG limit that will be given. So as per the weight that we load onto it, we can calculate using the graph where the CG falls. It could be to a limit, a certain limit to the forward and certain limit to the aft, and not more than that, because this aircraft is nothing but another machine. It has its own stress levels, basically. So when you cross the CG limit, what happens is either the tail will or the nose will have some cracks, which might hinder the aerodynamics of an aircraft. So to keep it within the limit, it's just like a normal ruler that you use, a plastic ruler. You have to maintain a balance, or if you just keep bending, putting more force at one end, it starts to break. A similar thing happens with any, not just the aircraft, any vehicle, or even the vehicle. If you see even the vehicle, their dynamics, the aerodynamics is used even in cars. And all these things, including the fans, the ceiling fans that you use, even that has the same kind of limitations in the front and back. So it is a general thing given in regarding this aircraft as well. And once the CG has been limited, and following that, if it is not in the limit, we either change the weights. If there is more of forward weight, we'll try to put it to the aft so that the CG comes to the center or somewhere towards the center for a better takeoff and landing and maneuverability.
Yeah. This is one of the reasons why, when you're flying in an aircraft, you have to arrive at the airport at least 2 hours before, because after you arrive there, after they weigh your luggage, there are other calculations which is required to do by the team members or the flight crew before they get thumbs up for flight. So basically they have to do a weight and balance, trim, everything they have to do. So that is one of the reason you have to arrive at least 2 hours before, for if it's an international, at least 3 hours before, to finish certain other procedures for flying.
Well, very true. I would like to add something on this as well. So basically, it's not so possible to weigh each and every passenger, because I might weigh 80 kilos and tomorrow I might weigh 85. It's not a standard one. So once they have a standard set of rules to calculate number of people who has bought the ticket and who has arrived to the aircraft, and then they will give an average figure, and then at the end they will check how much weight is left over or how much weight has been added up. Based on that, we will even calculate on the amount of fuel. The more fuel we use, the more weight we'll carry, which will make us to burn more fuel again. It's a different concept. The more the weight has been added, we burn more fuel. So we'll try to take the required amount of fuel for a safe flight from point A to B. That is what we'll try to take generally. And second thing is, if at all in the last moment some passengers are not showing up, so what happens? It's kind of dynamic. So we'll have to reduce the amount of weight that is not being taken up, and the whole calculations also changes a little bit. So it's always good to be arriving early and then wait rather than missing the flight after coming a little later. That's what it is.
So now this will give you an idea, like generally, like why should you go a little bit early to the airport, unless railway station or bus station where you can go and board the bus or a train at a last moment. But same thing cannot be done at an aircraft. Simple reason is, bus or train, anything happens, you can stop it immediately. But aircraft, once after takeoff, anything happens, you have to land. There is nothing called stop or somewhere in between. So that cannot happen there. So you have to plan your flight before you take off. Okay. Now we come on to the primary control surfaces. So as shown in these two videos, we have three primary control surfaces, basically controlling the aircraft. Ailerons, basically the ailerons are on the wing, which will do the rotation. That means you want to either turn left or turn right, roll left or roll right, you use the ailerons. Then we have elevator. The name itself suggests that it is elevating. So you want to pitch the nose up or pitch the nose down, or increase the angle of attack or decrease the angle of attack. It is done by using elevator. Then we have rudder. You want to yaw left or you want to yaw right. So you have the rudder motion. Basically, when you go for training, you'll be first few hours, you'll be learning what are the effect of these controls, how to control the aircraft by using these three things. It is something like ನೀವು ಸೈಕಲ್ ಕಲಿಯಕ್ಕೆ ನೋಡ್ತಾ ಇದ್ದೀರಾ, the first time when you try to ride a cycle, you will not get that perfect balance. So it will take few hours for you to by using all these things. Now we come on to the second type of control surfaces. These are basically to enhance the lift. To increase the lift, we have the secondary control surface, that is flaps, slats, spoilers, air brakes, tabs. Of course, spoilers and air brakes are basically to decrease the lift, so that comes separately. All these control surfaces, that is the secondary control surfaces, are not mandatory. That means it need not be present in all the aircrafts whatever you built. Depending on the type of the aircraft, depending on the how big or the portfolio of the aircraft,
the speed of the aircraft also determines.
Yeah, the speed of the aircraft. You add up flaps, slats, all these things. Basically, all these things improve the flying performance of the aircraft. I'll show you a small video on this, so you get a better understanding.
Over the last few decades, airplanes have certainly revolutionized the way we travel. But have you ever thought of how it flies? How does it navigate? We will get answers for these questions from this video in a simple yet scientific way. We will also explore how the flight is controlled in a real-time manner. First, let's look at some history. Many crazy flying machine designs were tested in the 19th century because of mankind's
I'll just forward it a little bit so that
thrust force chamber and turbine stages. The engine also derives the thrust force from the fan's reaction. Let's look at the wing.
Yeah.
You can note that the wing of a modern aircraft is a collection of different parts. During the takeoff, the flaps and slats are extended downwards as shown. This increases the...
Now here I just want to mention, see the red markings, what you see here, the red structure, what you see are basically the flaps. Flaps are closely attached towards the fuselage of the aircraft. The place where the wing is connected to the main structure, and you have the ailerons over here, which will be after the flaps. The green structure, what you see here.
The wing area and curvature of the airfoil. As the curvature increases, air will be deflected more. Thus, a greater lift force can be derived even at low airplane speed. As the airplane speed increases, the lift force rises. Finally, when the lift is more than the gravitational force, the plane takes off.
So basically here, the flaps and slats are just increasing the surface area of the wing. By doing that, when the surface area increases, what happens is the total amount of lift also increases at a lesser speed. That's what it's the main reason for slats and flaps.
And one more, when you're having a big aircraft, basically you use slats, you use flaps to increase the lift, and then the it also decreases the amount of runway or amount of length of runway run which is required to lift off.
So yeah, basically it is like at a lower speed for the same amount of speed. If you need more lift, so you increase the surface area of the wing, which will give us immediate. I mean, at a lower speed, we can have it's called a velocity of lift. So we will reach that certain speed at which lift off can happen based on the amount of flaps that we use, flaps and slats as well.
During the normal flight, flaps and slats are put into its original position. It is interesting to note that different forces acting on the airplane balance exactly each other during the normal flight. Now let's get into the core of the flight navigation. You can navigate the airplane the way.
Okay. I also have just one more video also.
Hello, this is Tim. Today we will talk about the secondary control surfaces of an aircraft. First, let's see what are control surfaces. Control surfaces can be classified as primary control surfaces and secondary control surfaces. The primary control surfaces are elevator, rudder, and ailerons. They are used to pitch, yaw, and roll the aircraft. The primary control surfaces are mandatory in all aircraft. Now let's look at the secondary control surfaces. Unlike primary control surfaces, these are not mandatory in all aircraft. These control surfaces are used to improve the performance characteristics of the airplane and also provide assistance in flying the aircraft. Now let's look at some secondary control surfaces. First, we will see the flaps. Flaps are located at the trailing edge of the wing. They are classified as a high lift device on the aircraft. Let's look at the cross section of the wing and the flap in more detail. The flap can only extend downwards. As it extends, the wing camber increases, which increases the lift force created by the wing. This is the lift equation. When the camber increases, the value of CL or the coefficient of lift will increase, so the lift increases. Flaps will have more than one setting or angle of deflection and are used during takeoff and landing. These settings are also called as configurations. Flaps are locked in a particular configuration by pressure brakes. During takeoff, flaps are extended to a small angle, and during landing, they are extended to the maximum angle. So the flaps provide high lift at low velocities. The next secondary control surface we will look at is the slats. Slats are the wing. They are also classified as a high lift device. Like flaps, the slats can only extend downwards. As it goes downwards, the camber increases, so the lift also increases because of the increase in CL. The main advantage of the slat is that it increases the stall angle, so the aircraft can fly at a higher angle of attack. Like the flaps, the slats also have different configurations and are used during takeoff and landing. In some aircraft, when they are flying at high angles of attack, the air is allowed to flow through the gap between the slats and the wing. These are called as slots. The next secondary control surface we will look at is the spoilers. The spoilers are located on the upper surface of the wing. They are mainly used to reduce the speed and the lift of the aircraft. The spoilers can only deploy upwards. This spoils the airflow on the top surface of the wing, which increases the drag on the aircraft. Spoilers are used in flight to reduce the aircraft's speed and to rapidly decrease the aircraft's altitude. They are used during landing to rapidly increase the drag to stop the aircraft safely. The difference between spoiler extension in flight or during landing is that the angle of deflection changes. The next secondary control surface we will look at is the tabs. These are the primary control surfaces of an aircraft. The tabs are installed on the trailing edge of the primary control surface. Let's look at the horizontal stabilizer to understand the working of tabs. This is the elevator and this is the tab attached to the elevator. The tabs can be classified as balance tabs or trim tabs. First, let's look at balance tabs. If the elevator has to be deflected down, the tab will be deflected up. The airflow will push the tab and the elevator downwards. Hence, the balance tabs will assist in the deflection of the control surfaces. So, if the elevator has to be deflected up, the tab has to be deflected down. Now the airflow will push the tab and the elevator upwards. This is extremely helpful if the aircraft has a cable pulley system for the flight controls. Now let's see trim tabs. These tabs are controlled by a trim wheel and are used to reduce the pilot's workload. To understand this, let's consider an aircraft flying with the nose up condition. Now the aircraft is said to be out of trim. For efficient flying, the aircraft must be flown straight and level, which means the aircraft needs to be trimmed for level flight. The pilot, however, cannot keep holding the control stick forward throughout the flight, so the trim tab becomes.
So here, trim tab basically reduces the load on the control column. Control column, what you say, in other words, where you control the aircraft, you control the elevator, you control the ailerons or the stick. Otherwise, what happens every time a pilot has to maintain a particular type of pressure on the control column, which is not possible at every instant of time, because it will be a physical strain also. So in order to reduce this, you have trim tabs. So you trim your tabs so that that elevator is adjusted or set to a desired level, and then it will let you off this the physical pressure on the control column.
Yeah, it is basically you can compare it with the normal door and door stopper. So you open a door to a certain angle and put the door stopper, it stops at that particular, so you don't have to keep holding the door open. So something like that. I hope they can understand this.
Once the tab is deflected up, the elevator gets deflected down and the tab is locked in this position. The aircraft is now trimmed because the elevator will maintain level flight without any pilot input. We have seen some secondary control surfaces such as flaps, slats, spoilers, and tabs. Depending on the airplane's requirements, one or more secondary control surfaces will be installed. Thank you for watching and please subscribe.
Okay. So now I think so you have some brief idea about all the primary and the secondary control surfaces. So now we'll go on to the next topic. The main thing, engines, aero engines. Of course, without engine also you can fly an aircraft. Basically, those are called gliders. Only thing is you have to again find out a method where you try to increase the speed. So one of the way is where you have a pulley, you have a cable attached to the glider, and then the winch will rotate. There'll be a drum on the winch, so the cable will get entangled onto the drum and it will start pulling the glider, and the glider, as it attains the speed, it lifts off, and then after a certain height you disengage the cable. So that is one of the way. Or you jump from the cliff of the hill with a hand glider. So that is another way. But having an engine gives you a lot of comfort because you have continuous thrust which has been produced. So earlier days when the aircrafts were made, even now also, like all the small aircrafts, the trainer aircrafts, basically they're all piston engine aircrafts. So they use piston engine because the power generated is enough for that particular aircraft. But when you go to a little bit bigger aircraft, weighing more than 3000 kgs and all these things, you go into gas turbine engines. So in this, there are two things. One is a turbo prop engine and one is a turbo fan engine. So basically, turbo prop engine, seeing the engine, you can make it out whether it's a turbo prop or a turbo fan. ಹೊರಗಡೆ ಪ್ರೊಪಲ್ಲರ್ ಅಂತ ಹೇಳ್ತೀವಿ, ನಿಮ್ ಭಾಷೆಯಲ್ಲಿ ಫ್ಯಾನ್. ಹೊರಗಡೆ ಫ್ಯಾನ್ ಇದ್ರೆ ದಟ್ ಬಿಕಮ್ಸ್ ಎ ಟರ್ಬೋ ಪ್ರಾಪ್ ಇಂಜಿನ್, and when you have the fan inbuilt, that is a turbine blade, then that will be a turbo fan engine. Both has their advantages of usage, especially on the commercial aspect. So now I'll just show you prop engine works. So ಇಲ್ಲಿ ನೋಡ್ತಾ ಇದ್ರಲ್ಲ, so this is basically
Hey guys, welcome to another one of our videos.
Basically, when I started flying here on non-scheduled flights, I was flying a turboprop aircraft, and Captain Raghavendra also started flying ATRs, which is a turboprops, and now right on he is flying turbofans, jet engines.
In our previous videos, we talked about the working of the turbojet engine and the turbofan engine. In this video, we have another important type of aircraft engine in mind. It is called the turbopropeller engine or the turboprop engine. The working of turboprop engines are very similar to the turbofan and turbojet engines. The engine has a series of compressors to compress the air. This compressed air is mixed with fuel and undergoes combustion in the combustion chamber. Now, this is where the construction of these engines differ from the other two types of engine. In turboprop engine, the exhaust thrust is sacrificed in favor of shaft power. This is done by extracting the additional power at the turbine stage. However, the propeller is not directly connected to the engine. Jet engines normally rotate at a speed of 20 to 25,000 RPM. If a direct connection is given, the tips of the propellers will reach supersonic speeds and produce micro shock waves, which will effectively disintegrate the entire propeller. To avoid this, the engine and propeller are connected together by a reduction gearbox. Now, you might be wondering, why do we need to go back to rotating propellers when we already have much more powerful engine types? Turboprops have their own advantage. They're extremely efficient at low aircraft speeds. Airlines have researched whether customers would rather pay less for a slightly longer flight or more for a short one, and a high percentage of customers stated that they simply just want to get to their destination. Extra time from 15 minutes to even an extra hour doesn't matter to them. This is the reason why turboprop aircrafts are used in shorter domestic airline routes. Besides the advantage of higher efficiency, turboprop engines are rugged too. Turbofan and turbojet engines are just as delicate as they are powerful. These engines can be rendered useless if any debris such as rocks, gravel, dirt, or even birds enter the engines. Turboprops, however, have far less issues with debris because debris is not sucked into the combustion chamber of the engine. The blades may get dented, but this does not cause the engine to fail. The most loudest aircraft record is held by a turbopropeller aircraft. The aircraft's name was XF-84H Thunder Screech. It was an experimental turboprop aircraft which was designed to fly at supersonic speeds. Because of this, the aircraft's propellers continuously rotated above the speed of the sound, emitting a continuous sonic boom. Well, that's it, guys. Hope you enjoy.
Raghu, you want to add on something to it since you have flown the turboprops for a long time?
Yeah, one of the major thing is like for turboprop, they need the density of air. Is one of the main thing for it to fly efficiently. So a turbofan, a jet engine like Airbus 320, it is efficient as it flies as high as possible. For turboprop, at a lower ceiling level itself, you can get a very efficient one. And the best part is it is very, very fuel efficient when compared with a turbofan engine. That is one of the main thing. And controlling this one is like more rugged, and the descent profile or controlling the speed is much more faster. I can't say it's easier because when you compare at times, flying it manually will be tougher than flying a turbofan engine. But only thing is about the speed, but which can be controlled very well with a turboprop.
Now we will also have a small video to see the working of a turbofan engine or a jet engine.
I'm Jake O'Neill, creator of Animographs, and this is how jet engines work. Most jet-propelled airplanes use a turbofan design. The turbofan can be thought of as a high-tech propeller inside of a duct called a diffuser, driven by a gas generator. The core. The engine is a gas generator that creates high-pressure gas to power a turbine. This setup has compressor, combustor, and turbine sections. The compressor. Compressed air makes for a much more powerful combustion reaction relative to engine size. Compression happens in stages that force incoming air into an increasingly narrow chamber. A single compressor stage is comprised of a spinning rotor paired with a ring of stationary stator vanes, which are attached to the core casing.
Now here you observe this turbo blades. So 1 minute. What? This one. If you see the shape of this the turbine blades inside, it is also a small airfoil. You can see, and you have one set of rotor blades and one set of movable blades, and the air gets compressed between these two blades, and it gets compressed, and it becomes super hot, and then you have again secondary set of high pressure turbines.
Rotor blades swirl the air as they force it through the compressor. Stator vanes slow this swirling momentum in exchange for increased air pressure. The compressor has 4 low pressure and 10 high pressure stages. The combustor. Air is mixed with fuel and ignited as it passes through the combustor, releasing a jet of super high.
At this stage, when the air comes out of the high pressure chamber, it's at a very high velocity and it will be superheated. Already it will be red hot heated. At this stage, you have the burn cans or the combustion chambers where just fuel is sprayed into it. Initially, to start this particular process, there is something called igniters. As you have spark plugs in your scooters or in your bikes or your cars, here initially to start the process you have igniters, but once the process or once the fuel is ignited, then you switch off the igniter and it is a continuous reaction.
High-powered gas. The design shown here is an annular combustor, meaning ring-shaped. Compressed air enters the inlet nozzles. Each nozzle is coupled with a fuel injector and is designed to swirl the incoming fuel and air for an even mix. A couple of igniter plugs, not unlike the spark plugs found in car engines, ignite this mixture, and the reaction spreads evenly around the ring. Once started, combustion continues as long as air and fuel are supplied. The turbine. Turbines at the rear of the jet engine are powered by exhaust gases exiting the combustor. Much of the turbine power is used to turn the fan, while a smaller percentage powers the compressor stages. Turbine fins get extremely hot. Some air from the compressor is diverted for cooling, and special coatings are used to keep temperatures down. The exhaust cone is specially shaped to mix and accelerate exhaust streams. It also covers sensitive internal engine parts. The fan. Early jet engines were turbojets, where all incoming air flows through the core. Most modern winged aircraft engines are turbofans, where only a fraction of air enters the core or gas generator, and the resulting power turns a specially designed fan. Again, the fan can be thought of as a high-tech propeller inside of a duct. Air that does not enter the core is called bypass air. High bypass engines are designed to move large quantities of air at slower cruising speeds, a range of about 310 to 620 miles per hour. The exchange for high efficiency is engine size. High bypass engines can be very large, with massive fans compared to core size. Commercial airliners or military transport aircraft are example applications. Exhaust velocity is a major factor in jet engine noise. High bypass engines surround fast-moving core exhaust with large quantities of slower-moving bypass air for quieter operation. Military fighter aircraft use low bypass engines, which are more compact, have high power-to-weight ratios, plus supersonic and afterburner capabilities, in exchange for things like poor noise control and high fuel consumption.
Okay. Now, so this I think so you have got a fair idea about the turbofan engine working. You can watch much more videos and get more understanding. And ಮಕ್ಕಳಿಗೆ ನಾ ಇನ್ನೊಂದು ಏನು ಹೇಳ್ತೀನಿ ಅಂದ್ರೆ ಈಗ ಅಮೆಝಾನ್ ಅಲ್ಲಿ you get kits, ಚಿಕ್ಕ kits ಸಿಗುತ್ತೆ, engine assemble kits. You can buy ಈ ತರ ಟರ್ಬೋಫ್ಯಾನ್ ಅಸೆಂಬ್ಲಿ ಕಿಟ್ ಅಂತ ಸಿಗುತ್ತೆ. ನೀವು ಆರ್ಡರ್ ಮಾಡಿ you can learn how to assemble ಚಿಕ್ಕದಾಗಿರುತ್ತೆ ಟರ್ಬೋಫ್ಯಾನ್ಸ್. So you will get to know each and every part of the engine, how it is working.
I'm Jake O'Neill.
Okay. Now, apart from this, now we'll just enter into flight instruments. What are the instruments we use basically when we want to fly? So one is an altimeter. So I'll just have a quick video on this. Basically, altimeter is used to indicate the height, at what height you're flying. To indicate that, we use this altimeter. So the principle in which the altimeter here.
As the name suggests, the altimeter displays altitude above mean sea level to the pilot. The altimeter consists of a flexible aneroid capsule inside a case.
You can visualize this aneroid capsule is a small capsule anta gottalla, the tablet capsule size. Adhe tara imagine ಮಾಡ್ಕೊಳ್ಳಿ. It's a small rubber type of capsule. And one thing you remember is ಮಕ್ಕಳಿಗೆ when you are on the ground, the pressure of air is different. Rather, the pressure of air is higher. You know what is the pressure of air? Is basically the weight of air which is sitting on the ground. As you go higher, as you climb higher, the pressure decreases. Now that is the calculation what is used to indicate the height.
The capsule expands or shrinks like a balloon when the static pressure changes as the aircraft's altitude changes. The static pressure is fed only to the case via the static port, which is exposed to the atmosphere around the aircraft. The capsule drives the pointer via a mechanical link to display the altitude in feet. In the atmosphere layer, where training aircraft fly, static pressure decreases at a constant rate. For demonstration purposes, let's assume that at mean sea level, static pressure has a value of 3 units. At 1,000 feet, it has 2 units, and at 2,000 feet, it has only 1 unit. In this example, the ground level is the same as mean sea level. The capsule is sealed with a fixed amount of air inside. Let's assume that the pressure inside the capsule matches the pressure inside the case. So both are 3 units, and the altimeter is adjusted to display 0 feet of altitude. When the aircraft climbs to 2,000 feet, the static pressure decreases. Inside the case, the static pressure also drops from 3 to 1. The capsule expands and drives the pointer to display 2,000 feet. Conversely, as the aircraft descends to 1,000 feet, the static pressure increases from 1 to 2, and the capsule shrinks, driving the pointer to display 1,000 feet. Should the static port get blocked, the static pressure will remain fixed inside the case, and a constant altitude will be displayed whether the aircraft climbs or descends.
And you see a small bar here. This is basically where you can set the preset values.
Lass dich inspirieren und entdecke Herbstoutfits, die genau zu dir.
This basically, for example, now Bangalore is approximately around 3,000 feet elevation from the mean sea level. Raghvendra, Chennai is how much? 40, yeah?
58.
58.
Yeah,
so Bangalore is 3,000. Now
yeah,
Chennai is, yeah, 3001 Bangalore is. So basically when you're starting your flying, because now imagine an aircraft is coming from Chennai and aircraft is coming from Bangalore, both are having different altitude readings, then there are chances that both can hit each other or both can indulge in an accident. So you should have a common nomenclature or common value. We have to arrive at a common value so that after certain height, these aircrafts will tune into that common value. So every altimeter indicates the same height or whatever the respective height they are flying from the mean sea level. So we call it as QNH. So this is the bar through this screw type of arrangement. We just turn it once we know what is the QNH value of that particular airfield. This value is transmitted through a radio communication at every half an hour intervals, and it is transmitted. Is that right, Raghvendra?
Yeah, we get it through the METAR or through the ATC, and there is another trick to find the exact barometric value. One is like once you know the elevation of the airfield, you can, for example, if it's Bangalore 3001 feet, you just keep changing the barometric value till you get 3001 feet. That will be the actual pressure, because that varies every day. I mean, based on the temperature at an airfield. Since morning, the pressure will be higher. When the temperature keeps increasing, the pressure decreases. So it will create a low pressure. So you'll have to set that exact pressure so that the altimeter will read the elevation of the airfield. That is one point. And after you take off, and there are preset values of something called transition altitude and transition levels. So once you are going from a transition altitude, you're crossing, say, for example, in Chennai, transition altitude is 4,000. Oops. So in Chennai, transition altitude is 4,000 feet. Right. So once you cross 4,000 feet and you climb to 5,500, we transit from altitude to flight levels. There we start changing the standard barometric setting of 1013.25, which is the standard ISR temperature. Sorry, ISR pressure. So that will that will help all the aircraft to maintain a certain level so that we don't collide with each other. That is the main thing.
Okay. Now I'll quickly just take you through this particular altimeter. You can see there are three indicators over here. One is a very thin and a very long indicator. This indicates feet in the height in hundreds of feet, 100, 200, 300. Are you people able to hear me?
Yes, sir.
Yeah.
Yes.
Yeah. So, and you find one more long and a thick needle. This indicates in thousands, and you find a very small. This indicates in 10,000s. So this is how the where you get the entire right. Now you can see the reading is something like it is pointed to 7 or 8. So it is around 8, yeah, something around 700 feet. Next, we will look at airspeed indicator, one of the main important to indicate what is your speed. Now, how this airspeed is working, we will just.
Hey guys, Joe here from Holding Point Alpha, and today we're going to be taking a look at airspeed. In this short series, we're going to cover how an airspeed indicator works, the differences between indicators. So you're probably aware of an instrument on the control panel of any aircraft, the airspeed indicator. But how exactly do they work? The answer is pressure. Now, to explain air pressure to you, I want you to imagine that you are holding your hand outside the window of a car which is sat at standstill. Not much to think about, right? Well, as the car's speed increases, you'll begin to notice a force on your hand. This is called dynamic pressure. As your hand begins to move through the air, it collides with more air molecules, creating a larger force on your hand. Now, pressure equals force divided by the area. Now, your hand is going to stay at the same area, so as the force increases, so will the pressure. On top of this, a force is exerted on us by the Earth's atmosphere. Now, you don't notice it, but it is called static pressure. So therefore, to calculate the total pressure, it is the static pressure plus the dynamic pressure created by the force through the air. But how does this relate to an airspeed indicator? Well, an airspeed indicator is hooked up to a system which measures the static and dynamic pressure and converts it into an airspeed that you can see on the control panel. Mounted on the fuselage or wing of a plane, you will find some funny looking tubes pointing in the direction of travel. These are called pitot tubes. These are hooked up to an expandable diaphragm inside a chamber, and as the airspeed increases, the pitot tube experiences an increase in pressure caused by the extra force of the air molecules. Now, another vent runs into this chamber called the static vent. This is located somewhere on the airframe where the airflow is minimal, normally at 90 degrees to the direction of travel, and runs into the opposite side to the diaphragm. Now, the static vent is not affected by the airflow and therefore measures the static pressure of the atmosphere. As the pressure increases in the pitot tube, the diaphragm expands due to the static pressure remaining constant. Being hooked up to a gearing system, as the diaphragm expands, the gearing system will also move, which will increase the needle for the airspeed on the airspeed indicator. So that's how an airspeed indicator works. Let's do a quick recap. So to calculate the total pressure, it is the dynamic pressure, which is dependent on force from the air.
So that shows the working. So I think so there are different marks over here. The green will show you the normal that is aircraft operating range, and then I think so the red will show never exceed speed. That means you are not supposed to exceed this particular limit. That is the aircraft. Suppose you exceed it is shown as 208 or 210, for example. Suppose the aircraft speed exceeds 230, the chances that the aircraft can get disintegrated in the air because the stress the aircraft will not be able to handle. So these are the indications. Now we come to one more instrument called VSI. Basically, in short to tell, the VSI will increase your rate of climb and your rate of descent. So this is a primary instrument which shows whether you're climbing or you're descending. So you can see this right now, it is pointed at 0. So in case the aircraft is climbing, at what rate it is climbing, it will indicate over here. You're climbing at 500 feet per minute, or you're climbing at 1000 feet, or you're climbing at 1500 feet per minute. Or if you're descending, at 500, if you're descending at 1000, it indicates the rate of the descent per 1000 feet. Now, this is an instrument which will indicate the turn. So this is called a turn coordinator. So basically, it will indicate whether you're banking towards your right or you're banking towards your left. And it also, the balance indicator, this also indicates whether you're slipping or you're skidding. Now you're taking your car or you're taking your bike and you're doing you're just turning at a very high speed, or you're turning at a particular speed. Suppose if your speed is very high, what happens? You tend to skid. That means you tend to move away from the curve. Suppose if the speed is very, very low and your curve is high, then you tend to come inside, which is called the slip. So same way, we have a ball over here on the center, which will indicate either you're skidding or you're slipping. It basically depends on the rate of turn, that is, what is the angle of bank you give and at what speed you're going to turn. So for an ideal thing, your ball, that is a correct coordinated turn, the ball has to be in the center. Otherwise, what you do, basically, you try to correct it by, for example, if the ball moves to the left, you try to step on the left rudder and try to correct it. Next, we have the attitude indicator. Basically, this indicates, see, whenever now without attitude indicator, whenever we are flying the aircraft, what we take as reference, how do we know that we are maintaining a level flight or we are straight? So we look at the horizon. You know what is horizon? It's an imaginary, it's a line where, not imaginary, it's a line where it seems that earth and sky both are meeting. So that is the horizon. So when we do a normal flight without this instrument, we try to keep our eye or the nose in attitude towards the horizon, which indicates, okay, we are in the level flight. But every time the weather is not so good, or you may not be able to see the horizon every time because of cloud and all those things. So you have an indicator called attitude indicator. It is basically a gyro. You know what is gyro? It's the principle behind this instrument is gyro. Gyro is nothing but bogri adtiralla chikka vayasale bogri suttodu. So same way, you have a gyro which is spinning at a very high RPM. That is the principle. That is altogether a different topic which we'll discuss, but this instrument basically works on that principle. And here you know, what is the amount of bank you are giving, or what is the attitude you are maintaining, what is the attitude the aircraft is maintaining. All these things are indicated through this instrument. And one of the main other instrument is your heading indicator. You remove earlier, like when the olden days of flying, they were only using this particular compass. This is literally the compass, the normal compass what you have. So you have a compass which has been fitted into the aircraft. And the difference between these both is the compass has a lag. That means you turn to a particular direction, the compass will indicate the turn a little late. Whereas we have this heading indicator which indicates instantaneously the turn. Suppose you want to turn from the north, that is 0 to 030, that is number 3 over here. So you can use this indicator and turn, but when you, at the same time, when you look at the compass will show a lag.
So one of the main reasons for this is because the heading indicator is a gyro and the compass has a liquid lag. And also it deals with, because basically the compass uses the magnet inside, which has the effect of the north and south pole based on the latitude on which you are in. So that will also help, is one of the reasons whether it is lagging or leading.
But initially before start of flight or during the flight, at every certain amount of time, we reset the gyro, that is the heading indicator, seeing the compass. Now, once we feel that okay, the compass is stable, we check the heading indicator. Both are showing the same values. If both are not showing the same values, we alter the reading of heading indicator. There is a screw arrangement given here to whatever the reading the compass is showing. So that has been done. I think so. In the modern aircraft, I don't know, this it has been taken care of
Modern
automatically.
aircraft, we still have a compass, but that is only for to check, cross check, but we don't. There is something called INS and IRS that we use, which is like a gyro itself, and it's more modern. These are the basic things that has been used in training flights. So we'll stick up for this for now. The IRS and INS now will level the aircraft position based on the GPS also.
Okay. Now the latest technology, instead of gyros, they're using lasers actually. So that is fun. Okay. Now we'll come into the main
laser
part.
is also, it's also called a gyro, laser gyros only.
Laser gyro. Okay.
Gyros.
The next important part we come across is suppose now as a child or you have finished your graduation, you want to now become a pilot. What are the things you have to do? So in India, the governing body for the civil aviation is DGCA. It comes under Minister of Civil Aviation. It is called Director General of Civil Aviation. So once you go into the website, I've given the website here, www.dgca.gov.in. You get all the details regarding to rules, regarding to like what are how many aircrafts, licensed aircrafts are there, how many operators are there, everything about the aviation pertaining to the rules, regulations is given over there. Okay. Now, as per the guidelines of DGCA, I've just taken those guidelines you should be not less than like 16 years of age in order to get your commercial, or in order to do start your training for a commercial pilot license, or in order to apply
for starting the training, and to get a CPL, commercial pilot license, you need to be 18 plus.
Yeah, 18 or 17, 18 years. 18 years. And the minimum qualification for getting the license is 10+2 with physics and maths as subjects. So this is like you have to get a DL. I think so nowadays you should have 10th masker. I think so. No, that is the rule which has been put out by RTO. It's a similar type of rule. Like you should have 10+2. But most of the pilots are nowadays they finish their graduation, they're graduates, or they are they have done other stream of education. But for flying, the thing is usually flying starts at an early age. So it is better that you start at an early age, somewhere 16, 18. That is where like you can learn better, or probably you learn the best. That is one thing what I'll suggest you. Flying is not as a regular job, or being a pilot is not as a regular job. Okay, one day you decide, okay, I am not getting work anywhere. Kelsa adu beda adu siktala it siktala, okay, I'm pilot ಆಗ್ತೀನಿ ಅಂತ. No, pilot has it's a passion which you have to build right from the childhood, and then only you'll be able to you should have a right aptitude. That is what we call is a flying aptitude to become a pilot. Not everyone are designated to become a pilot. The chill or the individuals who are having this flying aptitude will be able to like finish their training and will be able to like work in airlines or something like that. So Raghu, you want to add something onto it?
Yeah, it's not something extraordinary to say. How do I put it? So see, even pilots or any other stream, it could be a scientist, it could be a pilot, it could be a doctor, or it could be a farmer. Everyone are normal, ordinary beings, because it's all man-made things. But only thing that differs is your interest in becoming a pilot. Or if for example, I was interested to become a doctor, I would have become a doctor. I wanted to be a pilot, that's my interest. And I saw one of the questions, what is the most toughest thing to be a pilot? The difficulty that we face. The main thing we face is patience. One has to have a lot of patience to be a pilot. That's what I feel. And the aptitude to get trained, as Subhash Anna told, we need to have the right attitude to be patient and to keep pursuing. That works a long way.
This is actually not for those who are not having any interest in aviation, but only, okay, it's a glamorous world, I'll try it out. if they're coming, I think so they might fail. Like you should have that kind of an aptitude, because flying is also a very skillful job. It is not going to be an easy thing. It's a highly skillful job. There are many students who have enrolled and who are not able to complete the training also. So generating this at an early age, having this particular type of flying, right aptitude flying will basically shape you to achieve your goals.
True, very true. Right. So the aptitude is what, the interest and aptitude is what is more important for you to focus into being a pilot, because it is something it's one of the responsible jobs that we do. Not to boast myself, but or not to exaggerate much. We not only involve ourselves, we also involve other passengers' life, which it's one of the most responsible and one of the most stressful jobs you can see. You can Google it, and airline pilot or a pilot comes under one of the most stressful jobs in the world. That's being said, reason being we act against the normal circadian rhythm. Like there is no specific time, there is no weekly specific day of off. You get a weekly off for sure for rest days and all, but it is not as such like every weekend you get an off, because we work mostly in the weekends also, and there is no specific like say we have Pongal, we have Diwali and all those things. There is no specific leaves for those specific days for pilots. And secondly, there are some things we act against the nature. Weather comes into picture, passengers comes into picture, and fuel comes into picture. And at times, we have to work, like say we take off in the evening and we land only post in the early hours of next day. And long haul flights and all, jet lag, everything comes into picture. And mainly is the medical. You have to be very fit and you have to maintain your fitness to be working as a pilot.
Yeah. And second thing is, now for example, you're flying and you're having a particular some problem with your engine, or the weather is not good. Now you're in the air. Now you don't have any time, or whatever the decisions you take has to be the right decision. If the decision if it's not a right decision, then you end up in an accident. So at that time, the level of stress would be really very high. So for example, you're caught in something called, there is an engine failure, or you're trapped in a very bad weather, you're unable to land. These are the times where the stress level goes very high. So usually when you do training, of course these types of conditions would not be there, but they will train you to so that tomorrow you have these types of conditions coming in, how are you going to face it? So you cover up with training and also with experience. Now the second thing is going to once you have decided, yes, I want to become a pilot, first check what is your whether you're medically fit to become a pilot. So that is one of the most important thing why I suggest anyone who is entering into this particular field. So initially when you join or when you want to do your medical, there is something called class 2 medical and then followed by a class 1 medical. But to do this medical, you have to log on to or you have to enroll into this pariksha.dgca.gov and generate a computer number. This is basically a registration number which is given to you. Using this registration number, you can apply for a class 2 medical. There are a list of approved doctors by DGCA. You have to just basically take an appointment and do a class 2 medical. In class 2 medical, the doctor will say you whether if there is some abnormal conditions or something where you will not be able to pursue. But after doing your class 2 medical, I suggest that you also immediately apply for a class 1 medical. Class 1 medical is done again by DGCA approved doctors, or by it is done by IAM, that is Indian Aerospace Medicine. So they do a thorough medical examination of yours in case you have anything abnormal which is not shown in your class 2 medicals. You can see it in the class 1 medicals. And if your class 1 medicals is through and it is approved, then there is no problem. But if your class 1 medical is not approved, then you cannot exercise your of being, or you cannot exercise the privileges of being a pilot, because the medical stands above everything. Above your license, the medical stands. If your medical is not, if you're not qualified for class, then your license is also equally disqualified. Like without medical, your license, you can't do the privileges of your CPL license. So always your medical has to be fit. And this class 1 medical, you do it every year. That means today you do a class 1 medical, it is valid for 1 year. Before the validity expires, you have to again renew it. So every year you keep doing it. So as I mentioned, a class 1 medical will uphold the CPL. Pilot having a CPL license and his class 1 medical is invalid or expired, he or she will not be able to fly. Okay, now coming on to the other requirements. Once you have done your class 1 medical, everything is through, then you have certain theory papers which you have to basically clear it out. So the general, these are divided into general and technical. So the general, in the general category, we have aviation metrology, then we have air navigation, and then we have air regulations. Books are available for all the three things, especially like most of them for air navigation, they try to attend some classes because you have other calculations which are not taught in your regular max. Which has been taught here, but I also say you can attend those classes, but you can also do a self-study and you can clear these subjects, basically metrology, navigation, and air regulations. The minimum passing marks for these subjects are 70. So when you get a 70, it is considered as a pass. Then you have two technical subjects. One is that is a technical subject are specific to the aircraft what you are flying. One is technical general, about the engines and all these things. Other is the technical specific. For example, I am doing my training in Cessna 152 or Cessna some other type of aircraft. I have to write a technical or a technical paper specific to that particular aircraft. After that, the thing what you have to get ready is with your RTR. This is called a radio telephony restricted license. Now, you will be using the radio communications in your aircraft. That means you will be trying to communicate to the ATC. So you're basically transmitting, you're using a transmitter. So to use a transmitter, you should have permissions or you should have a license. So there is a particular examination which is conducted by Wireless Planning Commission. And once you clear this exam, you get something called a RTR, that is Radio Telephony Restricted License. This is also a must. So what and all you require? You require to fly an aircraft, you require your medical, class 1 medical, you require your radio telephone license, RTR, and then you require your CPL license. These three things are main for you to fly any type of an aircraft. Now coming on to the what are the flight syllabus, what you learn in the flying, how much amount of how many hours should you fly. So basically you'll be doing a training for 200 hours of flying. So in this 200 hours, you do 180 hours on a single engine aircraft and 20 hours you do it on a multi-engine aircraft. Multi-engine means aircraft with 2 engines.
I think Subhash, are we reaching to the end? Because due to the data thing, no, subjects are leaving. They will have 1 hour, 1.5 hour data thing.
Okay, so I'll just come. Yeah, another 5 minutes.
This chart is plotting the coefficient of...
Okay. Now, in the flight training, what are all the things we are going to cover? These are some of the exercises we'll be covering. That is, you will have a pre-flight check, engine start, climb, state and level flight, turn, stall, spiral. I'll just show you one of the video, how basically, so this is one of the... So this is something called a spin. How to do a spin? Suppose if your aircraft gets onto a spin, how to recover. Aircraft is heading onto a stall. Now you see it is entering into a spin. And then you recover from this spin. It looks more, oh, what is this happening? But it's real fun. So most of the pilots, they undergo all this training, like accidentally your aircraft enters a stall or enters a spiral or enters a spin. How do you recover from that particular thing? So all these things you get trained on. Next is your cross-country navigation. That means you fly from, for example, Bengaluru, you fly to Mysore. Bengaluru, you fly to Delhi, or Bengaluru, you fly to Bombay. When in your training days, there is no GPS which is given. Basically, they'll give you maps. You have to do map reading and you have to plot on the map what is the direction and what are the checkpoints you are going to read on the while you are flying. So all these things you do it in the navigation. Then you have descent, landing, and once you finish your the normal course in CPL, we have something called IFR. That means using instruments for navigation and using instruments for approach and landing. So this is some of the part. So I'm just skipping all this. These are the two multi-engine aircraft which I have flown. I and Raghavendra and Paresh have flown. This is Cessna, which is a multi-engine aircraft. And then
that is a Seneca.
Seneca, Piper Seneca. And this is a Cessna single-engine aircraft.
There is a message from Paresh.
Oh, okay. Okay, so I'll just
read it. I think what is the message? We'll show some videos on air sports activities. Okay.
Yeah. Okay. Now I think so. This is another section which I would like to cover, but now since the time is running short, Raghu, can you just quickly tell them what is type rating and then?
Yeah. So basically, type rating is like, we have been mentioning about different types of aircraft. So once we are done with your basic training and we are going for an airline, you fly that specific aircraft which the airline owns, like what the fleet of airline is. So it could be an Airbus, it could be an ATR. So what you do is you start from scratch to learn about that specific aircraft. It's a technical. Can I continue?
Yeah, continue.
Yeah. So once, for example, once you go on an ATR aircraft and there is a set of, Subhashana, can you just play that video? That will be more helpful. So it's not an actual aircraft. And then they trained in this kind of simulator where they simulate the real flying experience and you do all your training in that.
With all of the tedious ground schoolwork out of the way, it's time to really start learning the Embraer 145 by beginning simulator.
So this is a simulator. Actually, what happens is now for when you go to a wide body aircraft weighing more than 4,500 kgs, you can't now use that aircraft for your training purpose. It is going to be extremely costly, and you can't do all the maneuvers in those types of aircraft. So they have something called as simulators, where you do all types of maneuvers, you do all types of emergencies, basically.
Later training. Each of these full motion Level D simulators are valued at approximately $15 million. This one in particular is powered by a series of hydraulic actuators on the ground that are so realistic that you can actually feel the bumps in the pavement as you're taxiing to the runway on a taxiway. That allows us to recreate emergencies and procedures in the aircraft that really simulate what it would be like to fly in the airplane, and that's why they're so accurate. Our instructors on board have a series of touchscreen computers that allows them to control the simulation, set weather, set our position, and really create the entire situation that we're recreating in the simulator.
So basically, Raghavendra has completed his type rating on Airbus 320. This is a similar type of simulator what he has he has been trained on. And you find these simulators even in India also, very close to Chikbalapur in Devanalli CAE. You have these types of simulators where they train on Airbus and Boeing. So
it basically they give you a simulation of all those scenarios like an engine failure or a stall. And since it is very, very costly to do it on a real aircraft, we do it on a simulator, and it almost feels the same. It's not much different, but it is not the real aircraft. That's the main thing. And once you're done with this training, you'll get type rated on that specific kind. Like say, I've done it on Airbus 320. I got type rated, and you will get it on your license as well that you are eligible to fly Airbus 320 aircrafts.
So now next, I'll quickly move on because I'm running out of time. What are the other careers in aviation? Basically, I've just listed out over here. Apart from pilots, you have air traffic controllers. I have just a small video. I think so you can play it later. Like air traffic controllers are basically, it's been controlled by Airport Authority of India. They have their own college. And to become an air traffic controller, you have to be a graduate with electronics or I think so it's electrical or electronics you should have. And they have their entrance test. And once you are selected, then you have 1 year of 1 or 2 years of training, which happens, and then you will be posted on to different ATCs around India. That is a very good profession, ATC, and it is also a highly stressful job. Then you have aircraft maintenance engineers, basically to the aircraft and all those things. You have a course, AME, we call it as AME. Then you have cabin crews. You have you can also become a flight dispatcher, basically who will schedule out the routes to fly and all those things. Then meteorologists. Then the front end operations, you have airline ticketing, ground operations, and airline cargo. These are different fields in like aviation. Apart from engineering, when you come to engineering, it's a different world. Now,
sir, you can share the link. YouTube links afterwards, sir.
Yeah. Now, basically, this is another like flying in armed forces. So if you want to enter into defense and then like you want to be a pilot in the defense forces, then the options are Air Force, Army, and also Navy. All the three forces have flying branch, but Air Force has a bigger flying branch. So you can enter to these forces via NDA, CDSC, Combined Defense Service Examination, or Air Force Common Admission Test. And there is also a special entry called NCC Special Entry. Suppose you have an NCC C certificate, then you need not write these entrance exam. You are qualified directly to the SSB, that is Service Selection Board testing. So this is a small, if you want to get into defense forces, then have flying. And apart from that, now I will take off, we have Paresh, who will be basically discussing or showing you about aerosports activity. What are the other aerosports activity? Now, pilot is there, but instead of without having a license, what are the other things can you do? You can do gliding, you can do paragliding, you can do hang gliding. Of course, microlight flying also you can do. Then aero modeling, hot air balloons, aerobatics, not aerobatics, sorry, skydiving. I have also the videos over here, but Paresh will also show you basically all these things. Paresh?
Yeah.
You're ready, no?
Yeah, ready.
Okay. Paresh, can you share your screen? I'll just say stop share. I'll stop it here. Now you can share your screen. Yeah.
Okay.
You can show from your camera. Yeah, that is fine. That's fine.
Yeah. Once again, all of you.
And Paresh, 1 minute. So thank you. I'm there because I have an appointment. I have to move now. So thank you. Thank you, Srinath sir, and thank you, Supriya madam, for giving us an opportunity.
You covered in detail.
I think so. The time I've told you 1 hour, but it is going more than that. But okay. I think so. There will not be a problem. No?
No, it's very nice. Thank you so much. I think you please proceed as per your plan.
Thank you. Thank you. Thank you, Raghu, and thank you, Paresh. You can
Yeah,
continue.
thank you, sir. It was nice.
Thank you so much, Subhashanan. It's nice being here as well. So we'll just continue. You can just carry on.
Yeah.
Thank you, Subhash sir.
Thank you, ma'am. Thank you, ma'am.
Okay, yeah. Good evening, everybody. Paresh here. I am more into aerosports activities. We do simple activities like parasailing, paramotoring, paragliding, microlight flying, powered hang gliding. Of course, microlight flying is part of, we can say it's part of aviation. It is nothing but a small aircraft. All these while Subhash and his colleague, they are talking about the aircrafts, how it flies. The same concepts are used in aerosports activity. Actually, aerosport is an offshoot of aviation. Aerosports activities are more for the common man, for the Aam Aadmi, or it is for everyone to fly. Aviation as such is a capital intensive industry, whereas aerosports, you need little less investment, and as the name indicates, sports, it is done more for recreational flying. Though some parts of some of the aerosports are even used for commercial activity, like you pay for the activity if you are not a pilot. But apart from that, basically it is supposed to be a recreational flying. We start with one of the tethered aerosport activity, which is called as parasailing. I have a small video. I will share this video with you. And after that, we will move on to paramotoring. Yeah, you can take a look at this parasailing activity, which is done at Jakkur Aerodrome here in Bangalore. And it is open for public. Basically, this is an introduction to the aerosport activity. With this, you can get an idea of how the aerosports is conducted. Yeah, in this video, we are showing how actually this activity is done. This is something like a small parachute. It is called an ascending parachute. You are hooked to the parasail. The parachute is called as the parasail because it is an ascending parachute. So you are hooked to the parasail, and then with the help of a tow vehicle, you will be pulled into the wind. And the same concepts that Subhash has been discussing all through, how the wing helps the aircraft to fly. The same concept works here. The parasail acts like the wing of an aircraft, and as you gain speed, when you start moving on the ground, the parasail will lift you up. You can see here the parasailer is just a few steps, 2-3 steps, and then he's airborne. He's already gained an height of about 100 feet or so. And as we continue to pull, the work that is done by an engine in an aircraft is done here by the tow vehicle. So the tow vehicle gives you the forward thrust, and in return for the forward thrust, you get lifted up in the air. And that is how we control the parasailer. How high or how long he can be in the air is decided by the person who is driving the vehicle. So you can see here, this is a nice, beautiful view of Jakkur Aerodrome. This activity is, as I told earlier, for the common man. Every student, every family member can participate. One of the safest activity when done by professionals. So, yeah, this is how the parasail looks, and one view of the landing. You can see here that it's really very safe, soft landing. All this happens because before the start of the activity, we will give basic training. We will tell you how this activity is done, and then you can participate. So this is one activity. I am now here with a close friend of mine, Mr. Srinivas. He is a manufacturer of the paramotors. So what I plan to do is I will put on the my mobile. I will go to the paramotor and I'll show you how a paramotor looks. And the paramotor is basically a free flying activity. The same principle that applies in an aircraft applies in the paramotor. I will show you the trike. Unfortunately, today in Bangalore, it is still raining. We have drizzle here. Or else my plan was to spread out the wing, show you the wing, and then how it is even to start the engine and how the paramotoring activity is done. My plan was there, but unfortunately today we can't do it. Maybe some other time we will do the paramotoring activity demonstration to you. Today I'll show you the trike and how it looks, and then it will be followed up with a paramotoring video. Again, one of the most upcoming and one of the most exciting aerosports. All throughout the world, this activity is gaining momentum. More so even in India, there are more number of individuals who are participating in this activity. Not just participating, now we have many individuals who are buying this equipment and they are able to fly on their own after a little bit of training. It's a very simple activity, safe activity, provided again, as I mentioned in parasailing, it is something that needs to be done under supervision. Once you are trained, then you will be able to fly solo. So, Kaustubh, shall we? Yeah, now I will take you to the paramotor. I'll show you how the equipment looks. Yeah, just a minute, please. Hello.
Sir, audible.
Okay, thank you. Yeah, I think I was on mute.
ಸರ್ ಒಂದೇ ಒಂದು ಇದು 5:30ಗೆ ಇದು ಮೀಟಿಂಗ್ ಕಟ್ ಆಗುತ್ತೆ ಸರ್.
ಹೌದು ನನ್ಗೆ ಗೊತ್ತು. I need just about 2 minutes. I'm not going to...
No problem sir, but I'm telling them.
Yeah. Now what you can see is the paramotor here. This is basically called a trike. It has a similar concept like an aircraft. It has a nose wheel and 2 main wheels which are used at the time of takeoff and landing. The two pilots, the pilot and the passenger, will sit here. In most of the cases, the pilot sits at the back here in the back seat. The passenger sits in the front. Then the glider, the paraglider, is harnessed here, and it will be laid at the back of the paramotor. And of course, we can show you the engine here. One of the world's best paramotor engines. It is used in small aircraft. It is called as the Rotax 503. There is a 4-blade propeller. Earlier, Subhash has discussed in length about how an aircraft flies. So when this propeller comes on, when it starts rotating at a particular speed, the glider that is laid behind the paramotor will get lifted up.
sometime back you saw the parasail, how when it is pulled, the parasail moves up. A similar thing happens here. When the propeller rotates at a certain speed, it creates enough thrust. The paraglider, the wing gets lifted up, and then the entire trike starts moving forward, and you get airborne. So this is one of the safest aerosports, but also safe when it is done under proper guidance and with proper knowledge. All aerosports and aviation is actually high risk, but it is also safe when I told that it is done with proper knowledge. So this is the paramotor. I have a video of the paramotor. Unfortunately, due to weather, I am unable to show you the wing, or else I would have laid the wing on the floor. I could have lifted it up on the ground and from the ground and showed you how the wing looks. But also there is shortage of time. So we will move on to the video. I will show you a 2-minute video and then talk about another aerosport activity which is called as the powered hang glider. I'll need just about 2 minutes for that, and then I'll be done with it. For more details, we will probably catch up some other time. Yeah. Kaustubh, show the video.
Okay.
Yeah. Here we have the video of the paramotoring activity. This is the trike. This is a solo trike. There's only one person. The pilot is flying this. But in most instances now a tandem trike is used. Tandem means 2 people. This is how the paramotoring is done. Of course, he is flying low just to show how it flies. But like an aircraft, this paramotoring activity can fly up to a height of about 8,000 to 10,000 feet. And since it's a recreational and it is a sporting activity, these aircrafts or these paramotors fly at a speed of about 50-60 kilometers per hour and can fly for about 3.5 hours maximum. So the range is about 150 to 200 kilometers you can travel. But this is not meant for traveling from point A to point B. This is mainly for a sporting activity. So this is how the paramotor flies. After this video, then now the first activity, parasailing, is a tethered activity. That is basically the participant is controlled by the person who drives the vehicle. Whereas this particular activity here, it is free flying, just like any aircraft. You can see here the views are good. It is actually amazing. It is a sport which almost any individual can take it up as a hobby, not as a profession. Profession also is possible. There are more and more paramotor pilots coming up in India now, because small-time businessmen, they like to buy this equipment and use it for recreational flying. And since they cannot fly, they need pilots to fly. So there is an option. You can even make a career out of this. Yeah, so this is the paramotoring. I will quickly show you a video of the powered hang glider. Just a minute, please. I will. Yeah. Now,
this is the difference. You saw the first video, it is the parasail. It is like a parachute. The second video and the trike that I showed you is the paraglider, the paramotor. It's basically same like the wing of an aeroplane. Whereas this particular activity, what you're seeing now is the powered hang glider. It is also called as the weight shift mechanism. The controls are entirely opposite when compared to your conventional aircraft. Sometime back when Subhash was talking, he said how an aircraft flies. When you are supposed to take off, you add power and then you pull back on the joystick. But in this case, you have what is called as the control bar. So the bar will actually move the entire wing of the powered hang glider, and the pilot and the engine, which is it is actually suspended. So the principle here is different. For example, if you were to turn left, if you need to turn left in a powered hang glider, you will move the control bar to the right. Whereas in the actual flying in the 3-axis aircraft, you will move your joystick to the left to turn left. That is the basic difference. Again, one more sport which is regulated in India. We need to have a license or a certificate to fly the powered hang glider. For paramotors, there is no certification. It is a self-regulated sport. Whereas the PhD, the powered hang glider, need certificate. Class 2 medical is probably required now, but it is again a very safe, simple, and enjoyable sport. So I think we are done.
No, it's an excellent, sir. At the end, you really give.
I have been brief to the maximum extent possible.
No. We should have had a more time, but it's
we will surely do that. In fact, my plan was to take you inside the cockpit of an aircraft in Jakkur Aerodrome. Unfortunately, for technical reasons and even due to weather, it has started raining in Bangalore. You know,
it's raining heavily.
So I was unable to get my staff, but we had plans of showing you all the instruments which Subhash has mentioned some time back. Yeah, there is a query here to take, how much will it cost to take a ride in paramotor and paragliding? Okay, good question. Paramotoring will cost, a joyride will cost anywhere between 2,000 to 3,000 rupees for a 10 or a 12-minute joyride, which is fairly sufficient for a beginner. Paragliding will also cost the same amount, but paragliding requires more effort in the sense that unfortunately in India and in South India, basically, we have less paragliding spots. Nandi Hills looks a good option closer to Gauribidnur from your side. Most of the students I know are from Gauribidnur. Nandi Hills is a good option, but it has still not started there. Paragliding also will cost roughly the same. Paramotoring is about 2,500 to 3,000 rupees for a 10-15 minute joyride. Yeah. We could do one thing, maybe next week or some other time, I will probably even, or those who are interested could come over and we could organize a parasailing and paramotoring activity for the students.
Yeah, that should be a good idea.
Yeah.
Thank you, sir.
I know there is a shortage of time, but
Yes,
I would like to keep this very simple. I am more of a field man. I will not be doing much of the academic part. I would prefer students to have an hands-on experience. I will be able to teach them actually how to fly.
Maybe one Sunday we should bring them to this Jakkur
We will do
Aerodrome.
that. We will surely do that.
We'll write the permission letter for permission and then bring the selected students.
Yeah, we will do that. We will do that. Yeah. There are some more queries here.
Yes, sir. Please, sir. Please answer it, sir. Whatever up to 5:30, I think that was
Yeah. Temperature of air does not matter for flying wing. What is that? Flying of wing move more fast than sound speed. How they produce sound? how the efficiency of plane engine calculated. Okay. Plane engine efficiency, this will be too technical. Not that as a pilot I cannot answer this, but there are two types of engine. I am not sure whether Subhash and his colleague discussed about it. There are two types of engine. One is called the IC engine, that is the internal combustion engine, and another is the jet engine. So each has its own advantages, and most students will know about an internal combustion engine, which is used in our regular two-wheelers or cars. And depending on the cubic capacity, the amount of fuel and air that is burned by an engine, that gives to a large extent the power that is developed by an engine. Of course, there are other technical aspects for an engine to develop power, but one of the main things is how much fuel and air mixture gets burned in the engine, to a large extent decides the power that is developed by an engine. So I hope I answered that question, efficiency of a plane engine. Yeah. A similar thing, now the internal combustion engine works on the principle of constant volume. So as I told earlier, the paramotor can work up to about 8,000, 10,000 feet. As we go higher up in the atmosphere, the density of air keeps reducing, and hence the volume of fuel air mixture entering into an internal combustion engine keeps reducing, and the efficiency of this engine starts reducing. Whereas the jet engines work on the principle of a constant pressure. So irrespective of the height at which the engine is flying, I'll use the word flying, but the jet engines can be used even for other reasons, not for flying purposes alone, but in any case. So irrespective of the height at which the engine is flying, a constant pressure is maintained, and the efficiency of a jet engine remains the same, irrespective of at what height it is flying. I hope I have answered the question, because it maintains, the jet engine maintains a constant pressure. Right, Srinath sir? You have been working on.
Yes, sir. I agree with you. Yeah.
And Paresh, and there is another question on the same one. There's something like regarding the speed of sound, which I'm not able to understand. Maybe if they can rephrase the question. I guess they are trying to ask why the sound is coming up when we fly more than.
No, maybe that is related to velocity. It looks like
that
Mach
is,
number. We are
we are talking
number
of
concept.
Mach number.
Maybe.
Yeah. Now this again, this is also quite technical. We will try to answer these queries in a better way little later on. Yeah.
I guess it's basically like this. I can't understand that anyway. So
Canada. Okay.
So basically, whenever an aircraft flies, not all parts will be at the speed of sound. Whenever as we spoke earlier, whenever the air is flowing at a higher speed over the camber of a wing, at times speed at certain structure or certain points will reach faster than speed of sound, which is called Mach 1. At that point of time, a vacuum is created post. There's a place called subsonic and supersonic level. Once you cross the sonic speed of, more than speed of sound, there is this sound effect that creates. That's mainly created because of the vacuum effect, and when the air radiator fills in.
That's called boom, right?
Boom, right?
Boom,
Yeah.
Right. Recently,
I guess they are asking about that specific sound. I'm not too sure what the question was.
Most likely it may be on the boom effect.
Boom effect, yes.
Yeah.
Supriya madam, is still time is there, or just take a decision,
No,
madam,
sir.
on the class? Yeah.
Harshit.
Please.
Harshit, 1 minute, sir.
Okay. Supriya madam?
Sir, Harshit.
No, ನೀವೇ conclude ಮಾಡಿ ಪರವಾಗಿಲ್ಲ.
Question ಕೇಳಬೇಕಂತೆ sir.
They are most welcome. They can ask questions even later.
WhatsApp ಅಲ್ಲಿ ಹಾಕ್ಲಿ, we can send the
WhatsApp
question.
ಅಲ್ಲಿ, yeah.
Kalshana,
They are always
we will try
there
to. No, we will try to associate with this Jakkur Aerodrome for more
Sure, sir.
like, because it is very near. We can bring some students, interested
Yes,
students.
yes,
We can
yeah.
forward their interest to our Paresh ji, and we can see students get maximum benefit.
Yeah, in fact, my
Okay, madam,
company where I work, Deccan Charters, has agreed. They have told that they will be able to show the students.
What we can do, sir? What
yeah.
we can do? There is a place near Gauri Bidnur. It's called Science Center.
Yes, I
where
know
we
about it.
used to fly drones there.
Yes.
Maybe sometime we should take this motor power glider.
We can do
because
that.
It's a very open space. That one like workshop or one exercise which we organize in summer, we can do it.
Yeah, yeah. Summer may not be ideal because Gauri Bidnur happens to be quite a hot place, windy and hot.
No, we will discuss
winter
with the
season
time
will be good.
when we can.
Yeah.
Yeah, that time we can discuss whenever either Saturday or Sunday.
Yeah.
We can. I will come forward with a fresh proposal how to conduct a program on that.
Okay.
Supriya madam.
Sir.
You can conclude, I think so.
Okay, sir. Okay. Sir, mute agide. Paresh sir.
Yeah. I thank you all. It was really a good interaction. Hope we can do these activities for the children on the field. That will be much more beneficial.
Sir,
because
we
a
are looking
hands-on
forward.
experience stays with them lifelong.
Yeah.
Yes, sir.
Sure. Yeah. Okay. That's
Sir,
all that I have to say. Nothing much.
Today we are not able to receive more questions, sir.
It's all right.
Some students, some children are waiting, but time is running up.
Yeah.
Sir, we are at the end of the session. Thank you very much, sir. Subha sir took all the things in front of us, so it was amazing.